Electromagnetic radiation quantities. Radiant energy is the energy carried by EMR. Radiant energy causes the detector element of the sensor to respond to EMR in some appropriate manner. Unit of radiant energy Q is joule. Radiant flux pi is the time rate of the flow of radiant energy. Unit of radiant flux is joule divided by second or watt. Irradiance is the radiant flux intercepted by the plane surface per unit area of the surface. It arrives at the surface from all directions within a hemisphere over the surface. Unit of irradiance E is W divided by meter square or W watt per square meter. Radiance is defined as the radiant flux per unit solid angle living on extended sources in a given direction per unit projected area of the source in that direction. The concept of radiance is intended to correspond to the concept of brightness. The projected area in a direction which makes an angle theta with a normal to the surface of area A is a cos theta. Unit of radiance is W watt per square meter. Spectral reflections pi is the ratio of reflected energy to incident energy as a function of wavelength. Spectral signature are the value of the spectral reflections of object averaged over different well-defined wavelength intervals. Compare the spectral signature of the object or feature by which they can be distinguished. Intersection of EMR with atmosphere and earth surface. The sun is the source of radiation and electromagnetic radiation from the sun that is reflected by the earth and detected by the satellite or aircraft drone sensor must pass through the atmosphere twice. Once on its journey from the sun to the earth and another after being reflected by the surface to the earth back to the sensor. Intersections of the direct solar radiation and reflected radiation from the target with atmosphere constituents interfere with the process of remote sensing and are called as atmosphere effect. The atmospheric constituents sector and observe the radiation, modify the radiation reflected from the target by attending it. Both scattering and absorption vary in their effect from one part of the spectrum to the other. The solar energy is subjected to modification by several physical processes as it is processed through atmosphere via scattering, observation and refraction. Atmospheric scattering. Scattering is the redirection of EMR by particles suspended in the atmosphere or by large molecules of atmospheric gases or water vapor. The amount of scattering depends upon the size and abundance of particles, the wavelength of radiation and depth of the atmosphere through which the energy is traveling, which varies both in time and over section. Though scattering will be uneven especially and will vary from time to time. Scattering reduced image contrast and changes spectral signature of ground object as seen by the sensor. Atmospheric absorption. The gas molecules present in the atmosphere strongly absorb the EMR passing through the atmosphere in constant spectral band. Mainly their gases are responsible for most of the observation of solar radiation via ozone, carbon dioxide and water vapor. Absorption relatively radius the amount of light that reaches our eye making the sense look reality to atmospheric windows. The atmosphere selectively transmit energy of certain wavelength. The spectral band for which the atmosphere is relatively transparent are known as atmospheric windows. In the visible part, transmission is mainly affected by ozone absorption and by molecular scattering. Reflection. The phenomenon of reflection, that is bending of light or the contact between two media, also occur in the atmosphere as the light passes through the atmospheric layers of varied clarity, humidity and temperature. Radiation from the sun, when incident upon the earth's surface, is either reflected by the surface, transmitted into the surface, or absorbed and emitted by the surface. The AMR on the interaction experiences a number of changes in magnitude, direction, wavelength, polarization, and phase. These changes are detected by the remote sensor and enable the interpreter to obtain useful information about the object of interest. The remotely sensed data contain both spatial information and spectral information. The spectral band from 0.3 nanometer to 3 nanometer is known as the refractive region. In this band, the radiation sensed by the sensor is due to the sun reflected by the Earth's surface. Reflection. Of all the interactions in the reflected region, surface reflections are the most useful and evolving in remote sensing applications. Reflection occurs when a ray of light is redirected as it strikes a non-transparent surface. The reflection intensity dependent on the surface, refractive index, absorption coefficient and the angles of incident and reflection. Transmission. Transmission of radiation occurs when radiation passes through a substance without significant attenuation. For a given thickness or depth of a substance, the ability of a medium to transmit energy is measured as transmittance. T, transmitted radiation divided by incident radiation. Data detection and output. The most important component of a remote sensing is the sensor detector, which records the variation of radiant energy reflected or emitted by objects or surface material. Different types of sensors are sensitive to different parts of the electromagnetic spectrum. The function of recording system is to convert the energy detected by sensor into a form which can be perceived. This is done by dividing the incoming energy by beams, splitters and filters into different wavelength bands and then converting energy in each wavelength band into electrical signal. The electrical signal is processed to give radiometric data for each band, which is recorded in digital format.